Hi everyone, today we are going to start 1.3, use midpoints and distance formula. Today is day 2, which is all about the distance formula. First, we're going to review the Pythagorean theorem. A squared plus b squared is equal to c squared. We use this when we are working with right triangles. So let's find the missing side lengths of these right triangles. For the first one, let's start labeling our A, B, and C value. Remember, the C always has to be the hypotenuse. To find the hypotenuse, look at where your right angle is and draw a line to the outside side. So that means that X is going to be our C value. Now, A and B can be either leg of the triangle, so I'll just call this one A and this one B. All right, so A squared plus B squared is equal to C squared. My A in this case is 2, so 2 squared, plus B, my B is equal to 7, plus equals C squared. All right, so 2 squared is 4, 7 squared is 49, is equal to C squared. Add those up, I end up getting 53 is equal to C squared. Now I don't really care about C squared, I want to solve for C, so I have to do the square root of each side to get C by itself, which means the square root of 53 is equal to C. I'm going to keep it like that because that is an exact answer. The square root of 53 isn't pretty when you plug it in your calculator, and I don't want to round my decimal place. So the answer is just the square root of 53. All right, for our second example, once again, let's look at where our right angle is. To figure out what my C value is, I'm going to draw an arrow to the outside side, and that means that 12 is going to be our C here. Once again, A and B, it does not matter, so I'll just call this guy A and this side B. All right, so A squared plus B squared is equal to C squared. So 5 squared plus X squared is equal to 12 squared. So 5 squared is 25 plus X squared is equal to 144. Now I need to get X by itself, that's the whole point here. So I'm going to subtract 25 from each side. So I end up getting X squared is equal to 119. Same thing, I don't care about X squared, I want X, so square root each side. And X is equal to the square root of 119. And I'm going to keep it like that because the square root of 119 is not pretty. The reason we're doing this is that we're going to start finding the distance between two coordinates. If I want to find the distance between these two smiley faces, one way I could do this is by creating a triangle. So if I go down and over, I just created a right triangle. So I need to figure out what this distance is. How I do that is I'm going to look at the lower part of my triangle, and I'm going to count the spaces. So from my smiley face to the corner of my right triangle, I move over 1, 2, 3 spaces, so I know that side length is 3. If I look at from my right angle to the higher smiley face, I go up 1, 2, 3, 4 spaces. So now I can use the Pythagorean theorem to find the distance from the smiley faces. So A squared plus B squared is equal to C squared. I will call 3A, so 3 squared, plus I'll call 4B, so 4 squared is equal to, and X has to be C. All right, so that becomes 9 plus 16 is equal to X squared. 9 plus 16 is 25 is equal to X squared. Square root each side. And 5 is equal to X. And that is the distance between the smiley faces. Next, we're going to talk about the distance formula. The distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. We're going to use this formula if our coordinates are not plotted on a coordinate plane, and we cannot use the Pythagorean theorem. So here we go. Find the distance between 4, 8 and 1, 6. I guess you could, if you wanted to, grab some graphing paper, plot these 2 points, make your right triangle, and use the Pythagorean theorem, but that is a lot of work. So the easiest way to do this would be to use the distance formula. So 4, 8 is my first coordinate, so I'm going to call that x1, y1. 1, 6 is my second coordinate, so I'm going to call that x2, y2. All right, so the distance formula is x2 minus x1 squared plus y2 minus y1 squared. So let's plug in our coordinates into the equation. So x2 is 1 minus x1, which is 4. I'm going to square that, plus y2 is 6 minus y1, which is 8, and I'm going to square that. Now I'm going to simplify everything inside the parentheses. So 1 minus 4 is a negative 3. I'm going to square that. Plus 6 minus 8 is a negative 2. I'm going to square that. All right, so now let's simplify the parentheses with the exponent, but we're keeping the radical. So negative 3 squared is a positive 9. Remember, negative times a negative is a positive. Don't let your calculator lie to you. Negative 2 squared is a positive 4. 9 plus 4 is 13. And if you plug the square root of 13 in your calculator, it is not a pretty number. So I'm just going to keep it as the square root of 13. All right, here's the last slide. These 2 multiple choice questions, we're going to find the distance between our points. I'm going to do the first one with you, and then the second one I want you to try on your own. So what is the approximate length of RS with endpoints R, 2, 3, and S, 4, negative 1? The first thing I need to do is label my coordinates. So I'm going to call this guy x1, y1, and this x2, y2. All right, so let's plug everything into the distance formula. So I'm going to have 4 minus 2 squared plus negative 1 minus 3 squared. Okay, let's simplify our parentheses. So I end up getting 2 squared plus negative 4 squared. This then simplifies to 4 plus 16. 4 plus 16 is the square root of 20. But if I look at my answer choices A, B, C, and D, we see that square root of 20 is not an answer. So if I plug in the square root of 20 in my calculator, I end up getting 4.5. And that is answer choice C. All right. So like I said, I'd like you to try this one on your own and see if you get the correct answer. So what is the approximate length of AB with endpoints A, negative 3, 2, and B, 1, negative 4? All right, let's see if we got the correct answer. So I'm going to call this x1, y1, x2, y2. Do the distance formula. I have 1 minus a negative 3 squared plus negative 4 minus 2, squaring that. So I end up getting 4 squared plus negative 6 squared. This simplifies to the square root of 16 plus 36, which is equal to the square root of 52. Once again, the square root of 52 is not an answer, but if I plug that in my calculator, I end up getting 7.2, which is answer choice B. So hopefully you got that. No.